half of you. Is that a reflection on me, or is that a reflection on how good my students are? That y'all chose not to put in the effort to learn? No. Pretty sure it's a reflection on you. Headphones up. No questions about numbers 1 or 2? Number 2?
Yeah, I did.
We'll get on number 1 though?
What number 1 we're talking about though? Like,
What do you mean?
Like which function you use?
It says
oh,
that you do not have to determine the final value, but if you know that the boat is traveling at 45 knots, then which model would be the easiest to use to determine the rate at which the motor is turning over in hundreds of RPMs?
I chose the inverse model.
But why?
Because it shows us the X.
And so what we need to keep in mind is, look at the language, the speed of a boat moves depends on. So that means that this is my dependent, or y, whereas this was my independent, or x. And so if I want to determine the rate at which the motor is turning over, I need that inverse model, x equals g of that y is 45. And so I will point out, can you use the other model? Yes. Is it as efficient as just substituting that in and plugging into a calculator? Heck no.
You recording this thing?
I hope so. Pretty sure I hit record. Alright, but we said we need to ask about number 2.
So why did I get a 4.5? I put the inverse model because you can substitute 45 knots in for y because it is a y value.
But let me see that again.
I got 5.
I mean, you just wrote out what I wrote in words.
I mean, I didn't, that's not complete, that's not what I would do. Because you can substitute 45 knots in for y because it is the y value. So 1, why do you know that? 2, so like you would need to indicate that up here. But the bigger deal is, because you can always, notice it even has a d right here, you can always substitute 45 knots in for y, right? Even this transformed linear model, I could substitute 45 in for y. For the model for the original data, I could substitute in for y. The whole idea is that I want y to be the input and x to be the output, so I can just substitute in and simplify. That's the detail that you wanted, that you were missing. So you had the right idea, inverse, and I was pretty sure that's what you meant, but did you give me that level of evidence? Does that make sense? And that's the difference. Okay. Number 2, remember to linearize data, which I think this tripped some of us off.
Yeah.
To linearize data, you got to know what kind of function would model the original data. What type of function would model this original set of data? Not exponential.
Is it quadratic?
This was a quadratic function, or a quadratic function. Function.
How do we know if it's quadratic?
Good question. We'll look at that in just a second. Quadratic function best models this data. And so what tells us what type of function you have? The rate of change, right? And so if you had taken the time, and there's lots of ways you could have done it, but if you had taken the time to go to a calculator, so here it is already loaded in. Remember, we can look at, so like I could do B2 divided by B1. That would be looking for a common ratio, right, or a constant factor. Is there a constant factor? No. No, listen, constant factor. Factors are things we multiply by. So it's not exponential. That's all I was trying to point out there. Right, so if it's some kind of additive rate of change, B2 minus B1, and drag and drop, is that constant yet? Nope, but now I try C2 minus C1, and it's not perfect, but is that fairly constant? Yeah. So notice if this is constant additive, then this would be what kind of rate of change? Because that is the rate of change. Huh? Listen to the question again. Right. What kind of function has a constant additive rate of change? Linear does. So this would be a linear additive rate of change. So what type of function do we have here? Quadratic, right? the type of function that would model that data the best would be quadratic. And so that's what we want to note here. A quadratic function best models this data because the rate of change is approximately linear additive. But notice all I've done at this point is identify what would model this data, what would linearize something that's quadratic. Remember, a quadratic has what parent function? X squared. So what would linearize that? Right. That's what we would want to notice here. A square root is the inverse of a square. So that should linearize the data. So what?
It goes constant linear, then goes back, then as it goes to like it goes quadratic.
Well, okay, so, and don't forget, it can keep going for forever. But, so let's say I have a column here that is constant additive. What type of function has a constant additive rate of change? Linear, right? So then the next column would be a linear additive. And a big thing to note about that is linear additive means it's x to the first, right? So what's going to be higher than a linear additive? So then the next one would be a quadratic additive, which would be x squared. What's one higher than that? Cubic. So like, I'm not saying that we will ever get that far, but it's not just that it's the next one's quadratic additive, it just keeps adding a power, right? So if we had a cubic additive, that would be x cubed. Let's say that's the rate of change, what type of function would we have? X to the fourth, quartic was the name of that. So notice the rate of it just always is 1 power higher, right? So like you could keep going past quartic even and get have a quartic additive rate of change, and then it's x to the fifth for the function, a quintic function, right? So it's always 1 power higher. And even constant additive, that's just a number, right? Can I do x to some power? Is there any power I could raise it to get just a number automatically every time? X to the first is right there.
0.
What is x to the 0?
1.
Again, remember, what is the exponent doing? Increasing by 1. Does that make sense? And so it's just always 1 power higher when you're looking at those differences. Okay? So Keyshawn, you go with, you have to identify the type of function so that you use the inverse.
Put it in the calculator.
And so you just focus on this part, I think, if I remember correctly, right? Yeah. But remember, to answer that question, because it's quadratic, we're going to take a square root to linearize it.
That's the part that's on the out.
Oh, are you cold? Huh? 100%, yeah. Does anybody need me to talk about 3A, B, or C?
Hold up. Yeah.
A real quick.
I'm trying to figure out why we have, Mr. Kenny, it's just like in biology or chemistry, you just have to remember the equation. If we showing you what the equation is, why do we have to tell how we got it?
Well, one, that's wrong. That is the incorrect equation.
Wait, it's still,
I did that one.
you told me yesterday, I didn't show you how I got it.
Well, also, you didn't show me how you got it, because here's the thing, Caleb. I need you to remember, I need all of you to remember, is this just about memorizing something and moving on?
No.
No, because my name is Mr. Kenny, and I don't give a dump whether you memorize this. What I care about is, do you understand? Can you think and can you explain your ideas? Because you are probably never going to transform nonlinear data in the rest of your life. But what you are going to have to do is you're going to have to take information you have, use logic to show me how you get to the end result, and you have to communicate those ideas. Those are transferable principles that will work for the rest of your life. So I need you to do that. But also look again. What does that say right there?
Cube otherwise.
So we needed cube root.
Oh, I didn't even read that.
Oh.
I didn't either.
Oh.
Like, you gotta make it difficult.
No, I need you to read. I need you to pay attention.
That means my original one wrong, but you
Uh-huh.
said check, you gave me the check.
I gave you a check, but that's because I believe I made a note here. I noticed that you had procedural error there, and based on this procedural error, those were correct. Right, so I read with your mistake. So if you make a mistake early on, but then you use that mistake correctly later, I recognize
So
that.
if it was quadratic, all three need to be right.
Yes, yes. Mm-hmm.
Alright, you can go on to 3B now.
Okay.
Write the equation down for 3A, B, and C. Just right now, I don't need no.
Well, this is the level of explanation I would expect.
Alright, that's A. Oh, that's B?
Well, I already have A. Notice I've already indicated cube root is this, so I'm trying to get B.
What? The only thing I forgot was the 3, really?
I don't know what you said. I assume you're mumbling about and complaining about not fully understanding things.
Okay.
But now y is equal to 3.2x plus 4.1. Now I'll point out, one of the things that you would want to pay attention to even justify this more is, why in the world did you cube in this case?
So y in the transform function was a cube root.
Right, but why didn't you solve for x? Why didn't you subtract 4.1 and go that route?
Oh, we took the inverse of, no, not that. I don't know how to explain it.
But what are you trying to get to? What was the end result that you wanted? You wanted,
Y equals f of x.
right, so want y equals f of x, so cube, right? To get rid of that cube root, so that we have what y is equal to. That's the whole thing. Yes, Jakeem?
So,
Can you write C, please?
I thought when it said, when it said it was taking the cube root, I thought that was the original cube root.
Well, remember, that was, so we get this model after linearizing by taking the cube root of the y values. So we take the cube root of y, and once we took the cube root of y, we got this linear
So
model.
that's the transform.
That's the transformed, right? Literally, it has the cube root transformation applied to the y. Okay?
Miss Ken, all I ask is, I know we ain't got it memorize, you don't want us to memorize it, but can we just write the equation? Like, I mean, it's just showing we know how to write the equation, like, why do we have to tell how?
Because you gotta justify yourself.
Like, it ain't like we solving a word problem.
Like a word problem.
Take the extra 5 seconds and write it out.
That's C.
I'm not done. What would I need to do to solve for x? Right? Because then that's the thing you would want to recognize is now I want x equals g of y, so I need to solve for x. How am I going to do that?
Inverses and properties of equality.
Inverses and properties of equality, so which inverse am I going to use first?
Additive inverse.
The additive inverse, so to create a 0, cube root of y minus 4.1 is equal to 3.2x. Now what?
1 over 3.2.
Times,
1 over 3.2.
say again?
1 divided by 3.2.
Thanks, sir. And so, x equaling g of y is equal to 1 divided by 3.2 parentheses cube root of y minus 4.1.
So that's the one you want us to tell how, because that's what you put on my how. I get the last one.
Especially that one, because a lot of students do make mistakes when they don't pay attention to those details.
We just showed the word.
Like, it's really, yeah, that's the thing that kills me, is like, you complain about it, but it just is not that difficult to just show your
Show
work.
your work on the first two?
I didn't explain the word, I showed my word.
On the first two?
Yeah.
No.
On the last one, no, on the last one, that's what you put.
Okay.
Yes.
Well, yeah.
I didn't show my word with numbers.
So D, this is the one you wanted, Preston, right? Did you do f of g of y or g of f of
I
x?
did g of x.
Okay, so remember we want to compose the original function, so g of f of x. And what you want to keep in mind to make your job easy is what's the input?
The x, or f of x.
Right. Remember x, yes, is the input for the f function, but f of x is the input for the g function. And so the main function I'm dealing with in this is the g function. And again, I have colored pencils and markers all over the place, and this can really help you, is if you color code things, it's the cube root of y, but my y is being treated as f of x, right? And then minus 4.1. And so what can I substitute in for f of x?
Why?
The original model, right? That's what's going to get substituted in. So 1 divided by 3.2 times the cube root of 3.2x plus 4.1 cubed. Make sure that you have that cube root over all of that, right? That cube is inside of the cube root. Those are details that you want to pay attention to. Minus 4.1. You want to pay attention to your parentheses as well, which is where the color coding can help. And now you have to pay attention to what cancels first, right? That minus 4.1 can't cancel the plus 4.1 because that's inside of the cube and inside the cube root. What can cancel right now? Notice, yeah, I would say that 3.2 times x and 1 divided by 3.2, that's actually outside of everything. That's the last thing that I can cancel. But those can cancel right now. So g of f of x equals 1 divided by 3.2, parentheses, 3.2x plus 4.1, right? Everything outside those parentheses is canceled, so I can drop those parentheses. Now what can cancel?
4.1.
That creates a 0. And so the order does matter, because if you don't pay attention to that, you might find or decide that functions are not inverses when they in fact are, or vice versa. But notice at the end, I get that f of g, or g of f of x is equal to what? X. So what do we know as a result? The functions are inverses, right? And you would need to note that at the end, right? That's the whole point, right? Compose those functions to confirm they are inverses, so g of y and f of x are inverses. As a general principle, you've always known that inverse function or inverse operations do what to each other? They cancel. What are g and f currently doing? They are canceling so that x is equal to x. That's really what we're saying, right? Does anybody want me to work the f of g of y, or we go with that one? We didn't make any mistakes on the f of g of y one.
I did the G of it. I got a question. How do you do that multiplication inverse on 3D?
Yeah.
Parentheses are gone, right?
You talking about here? It doesn't matter in this case, because there's nothing else being grouped. So the parentheses can be gone or they can be left there. I'm going to show you just one detail with f of g of y quickly then. The most common mistake I saw if students went this route, especially if that 1 divided by 3.2 is at the back end, is they tried to do the negative 4.1 plus 4.1, which eventually you will, but you see how that minus 4.1 is inside of parentheses? So can you add those together yet? No. You would have to use these multiplicative inverses to create the 1 first.
Yeah, that what I did on 3D.
Does that make sense? So that was the issue.
So I had to take
I mean, both is
So
cool.
the first step would be,
These
Yeah.
would create a 1. You can't add those together yet because it's grouped together with the cube root of y first. And so once that creates a 1, 1 times anything is just that anything, right? So I would still have the green set of parentheses, but the black set would now be gone. I would have the cube root of y minus 4.1 plus 4.1 cubed.
So is that the
Yeah,
easy
we'll
way?
take the
Can you
cube
do a
root.
lot of easy way?
Oh, no, we'll take that.
So those would, right, because those are together, right? The cube is outside of all of that. Cube root of y cubed, and left of y.
That gotta be the easy way,
I don't know,
right? Gotta be.
I didn't think so, but I think they're the same in level of difficulty. But it's not like you're gonna know ahead of time which one's easier than the other. Technically, you're supposed to do both, I just asked you to do one, right? So compose the original function and the inverse as this or this. You only had to do one. Yep.
How do you proceed, or was it my first operation or the whole equation?
We're about to look, so like your final answer was correct. So yeah, let's look at this one. You could do either inverse on number, or either composition on number 4, to realize that they are not, in fact, inverses. And this was supposed to be an x. So f of g of x, if I were to look at it that way, what's my input? G of x. So if I do that, right, I've got something squared, well, g of x squared. I'm just going to go ahead and jump into, put that in for the g of x, squared plus 3. Well, the square and the square root are right next to each other, so they're going to cancel out. And so I'm left with x plus 3 equals x plus 6. And so I can just stop there. Are those going to be inverse functions? No. They're definitely not, right? So I can just stop there. But some of us did it the inverse order, to g of f of x equals, now this is my input, right? So I get the square root of x squared plus 3 plus 3. Right? Here's the thing though, the square root can only cancel the square if the whole thing is squared. And so I want you to notice, if I take the square root of 9 plus 16, with you taking the square root of just that square, just that one term, that's like taking the square root of just this 9. What's the square root of 9? 3. Okay, and then what's the square root of 16? So 3 plus 4, which is 7. But that's very incorrect. What is 9 plus 16?
No, it's 15. 25.
What's square root of 25? So not 7, right?
So I gotta simplify the radicand.
So you'd have simplified radicand first, and it'd be 3 plus 3, which is 6. And I just can't take a square root. The whole thing would have to be squared in order to take a square root, right? Which is why you have that procedural error. Now, you correctly recognize that they are not inverse functions, and so you still earned a pretty decent score on that, I believe. But that's the big thing is, we need to recognize if they are inverses, what should I have at the end?
X.
Right. So f of g of x does not equal x, so they are not inverses, inverse functions. That makes sense? Now, I will point out, a student from first block did a great thing here where she was like, I didn't know how to do the composition, but what she did know about, what are some other things we know about inverse functions? They are a what? Remember, opposite only means additive inverse. Think about them graphically. What do we know about inverse functions? They're reflections across, right, y equals x. And you should know, and she put it on a calculator, but x squared plus 3, that's a quadratic that's just been translated up 3. And so it would look like this, roughly. Whereas the g of x is what type of parent function? Square root, that's been translated to the
y 3.
So up 3?
Yeah, up 3.
To the what? Is it up 3 or left 3?
Oh, left 3.
It's inside, so it's horizontal and it's to the left. So this would be a square root function that looks like this. So is that a reflection across y equals x?
No.
Definitely not, right? Now we would want to remember that when we do a reflection, we actually do need to limit the domain. But if you sketch that out, this point 0, 3 would become what point across y equals x?
3, 0.
3, 0. So you can already see it right there. Are those the same? Would this reflection create this black function? No. Does that make sense? It would have had to be x minus 3 or x squared minus 3 for it to work. Okay. Do I need to go over number 5 at all?
Yes.
Okay. So remember A, the final amount, that's all that A is. What is P?
5,000.
5,000. Remember, that's the initial investment.
So P is always gonna be the. That's the value.
It's the initial, a better way to say it is initial value. When talking about money, it's called the principal, which is why it's a P. Right? So with money, it's called the principal. Alright, what is R?
The rate, which is 2%, that
Okay. So remember, the rate needs to be as a decimal. Okay?
Then K is 1. I mean, K is 12. K is 12.
A lot of us thought 1, but what do we mean by K?
This was the about. It's like 12 years. 12 months.
So remember, it's the compoundings per
So
year.
here's the compounds.
K is the number of compoundings per year. Okay?
6 at a time.
And then the T is time, which is 6 years. Once you identify everything, it's just about substituting it in. Done. Right? Substitute that into, or plug that into a calculator, find what it equals. So that detail about the K got quite a few of us.
Yeah, I was so confused. I was like, should I put a 12 or should I put a 1?
If I had a 12, I would have got 6. If I would have put 12,
Yeah.
I
I put a 1.
I was finna put the 6
I ain't putting it.
You should put like at least 4 of these on the test.
Huh?
You should put at least 4 of them on the test.
4 of them?
Yeah, like the 10.
I'll put a couple. To see if you recognize the different compoundings and things.
This, that's it. Just this.
This, the understanding check, and more with logarithms. Some of the stuff we'll cover today.
Alright.
Okay. So remember, there's still the other understanding check where you have to interpret the slope and the y-intercept in context,
That's
create a trend line that models the data, linearize the data, stuff like that.
I do 6 for me very quick.
6?
Yeah, do that. Most definitely.
Y'all killed me on A, some of y'all.
Ooh, I was so confused.
What-
It's only 5
I was
of them.
confused on it for a hot 5-10 minutes on it. I was super confused.
What type of function is it?
Exponential.
It's exponential, so what's the inverse?
A logarithm.
Wow.
So like justifying it, right? Inverse of exponential is logarithm. And what would the base of that logarithm need to be?
Or
3.
3.
The base of a logarithm is the same as the base of the exponential, right? Okay. So log base 3 of x, but to use proper notation, what do I need it to equal? To indicate that it's an inverse function.
X.
That's like
3. 3.
What's the question?
So there's two things you could do. You could do x equals g of y, which I think maybe that's what you were thinking about, Caleb.
Yes, sir.
But then you'd have to do y there. But remember, if I'm going to look at a graph like this, the input has to be x, right? And so remember, this is the way that the textbook had it. Not ln. Remember, ln is only of what base?
10.
Not 10. E. Remember, it's called a natural logarithm because it has the natural base, right? What does this need to equal? What was the notation for an inverse function?
X, Y. Oh.
No, we did H. We did H.
Oh,
It went L, it was H. H and L, yeah. Miss Kitty, it was H. We use H in the book.
You with that?
I see what you're saying. But if I start with G,
You gotta finish.
I gotta finish with G.
But the same thing, H, do the same thing.
So what we can do is if you have y equals f of x, you can change it to x equals g of y, right? But if you're using that inverse notation, if you start with g, you have to do this because literally what that's telling you is the inverse of g of x. Does that make sense? So I see what your issue with that was now. And so I would have accepted this notation if you had used it, but the more proper, so like that might have been a 5 or a 5.5 with explanations, right? The more proper notation, if you're showing clearly that's the literally inverse function of f of x, is that notation. Okay? So what were we supposed to do to accurately sketch the graph?
Alright, draw a line right there.
Right, so first off, remember it's a reflection across y equals x. And this is my fault, and I should have thought through this, and I'll update this for the future. Remember, the slope is 1, the y-intercept is 0. I saw people just trying to go like that, which makes sense, except, remember, it's rising 1, running 1. It's because the horizontal grid looks, is longer than the vertical grid. That's why it did that. But notice this is the line y equals x.
So the X and Y, switch, right?
And so that was the big thing to pay attention to that would have really helped you here, is that the x and y switch. So 1, 3 became 3, 1. This 0, 1 became 1, 0. Right? Negative 1, 1/3 became 1/3, -1. And 1/9, -2. And so remember, it has to approach the y-axis. I understand like struggling with that, trying to reflect it, but you gotta know that it's approaching the y-axis, and that's it. It should never cross that y-axis.
I just reversed. Cause I knew it was gonna be a reflection over the way.
Yeah, I know, so I just drew the line, I didn't even think about it.
Does that make sense though? So you want both those things, and the reason why just drawing a line y equals x and trying to reflect over didn't perfectly work here is again because of the way that that's set up. Notice it doesn't even look like that's perpendicular, but if this was a true grid where each of these was a square, that would have been perpendicular.